Today, we will present preface A of the Capstone 1 of our selected Baja site project. The members of the project are Gabriel Colón, José Borges, Anthony Peña, and Heriberto Coto. In the following section, we will discuss user and stakeholders, relevant information, description and objective, project significance, preliminary requirements, system level and constraints, and preliminary planning. The user for the Baja site are us as a student of the Polytechnic University or any student who is interested in this project. The stakeholders are the Polytechnic University and the Mechanical Engineering Department. Baja site. Engineering students are tasked with designing and building a single-seat, all-terrain sporting vehicle that is to be a prototype for the reliable, maintainable, economic, and economic production vehicle that serve as recreational user market. The student must function as a team to design, engineer, build, test, promote, and compete with a vehicle with the limits of the rules. Baja site is divided between two events, which are the static event and the dynamics. The static events are usually held for the first 2 days of competition. Static events consist of technical inspection, cost, design judging, and sales presentation. This event has a total of 300 points. And the dynamics events are usually held for the final 2 days of competition. The first dynamic day includes the following events: acceleration, track to event, maneuverability, and specialty events. On the second dynamic day, an endurance race is held. This event has a total of 700 points. In the next slide, each test of the static and dynamic event will be explained. Technical inspection of static events. The vehicles are checked by inspectors to make sure that teams adhere to the rules and safety standards set by SAE. It's required frame pre-check. All teams must submit their frame documentation and frame drawings. Other parts of the car that are checked include the fuel cell, firewall, seat, and harness mounted. The validation of this test is passed or not. Cost event may consist of a maximum of 3 sections: overview, costing sheets, and cost documentation. This event has a score of 100 points. Design judging. Teams have the opportunity to defend and explain the reason used behind designing their vehicle. This event has a score of 150 points. Sales presentation is pitching to a panel of hypothetical manufacturing companies to try and combine them to push the team's vehicle design. The presentation is limited to 10 minutes. This presentation has a value of 55 points. This event will be scored based on content of the presentation, organization of the presentation, effectiveness of the visual aid, speaker delivery, and the team response to the judge question.
Concept of operation. SAE Baja concept operation is especially event, maneuverability, acceleration, concept of operation. The concept of SAE Baja operation is especially event, maneuverability, acceleration, traction event, and endurance. Operational object. The concept that will be present below are the dynamic tests of the SAE Baja and their score for each test. Acceleration. In this measure of the acceleration of vehicle, its straight run of 30 or 45 meters from the standing exit. The faster time get more points. Maximum point of this event is 75. Go to sample video. Maneuverability. This test is designed to evaluate the holding of the vehicle. The course consists of variety of challenge, possibly including time pylon maneuvers, road drop-off, sand, rock, guidance, locks, and climb. Maximum point for this test is 75. The sample video is okay. Traction event. This test consists of climbing a slope while pulling a designated object. Maximum point for this event is 75. Go to sample video. Specialty event. This test consists of the testing of the SAE Baja in extreme off-road conditions to determine how much capacity the vehicle has and if it can meet the high test standard. This test is one of the strongest in the SAE Baja. Maximum point for this test is 75. Go to the sample video. Endurance race. Finally, we have the endurance competition, which consists of driving on all-terrain circuit for 4 hours. In this way, all elements of the vehicle, its resistance and performance are tested to obtain the most points. Completing this test gives us a lot of points to win final SAE Baja competition. Maximum point for this test is 400. go to the video. Okay, this is the final. Description. The competition of SAE Baja take it to a string of the string, the off-road capabilities of the vehicle, determine ruggedness, damping, resistance, reliability, and other tests carried out in extreme terrain such mud, stone, roads, sand, water, and jumps. Object. Design and build a mini Baja which is competitive and meets the standard to get the highest score and win the SAE competition. Project significance. During the SAE Baja project, knowledge of automobile engineering will be acquired when designing and manufacturing of road vehicles. This will prepare you as mechanical engineer and help you to better understand the function of the all-terrain vehicle. With this experience, we can develop and work car factory and innovating the concept for the manufacturer for vehicle.
Good night, everyone. My name is Jose Borges Burgos, and tonight I will be presenting to you with my group the pre-phase A of our Capstone 1 project, in which we will design and assemble a SAE Baja vehicle. Among the parts that I will be presenting to you today are the preliminary requirements of the system and the measures of effectiveness and performance. The most important part of this project is to achieve a design that provides the driver with full safety, since the different scenarios that the car faces while it is in competition can affect the driver's health in case of an accident. Each of these students will be responsible of designing under SAE standards, whether it be tires, suspension, and brake system, while maintaining a quality similar to ATVs, all-terrain vehicles, in other words. The chassis will be assembled and welded with steel pipe so that it has the necessary hardness. A series of analyses will be carried out on the assembly to guarantee its performance, and we will be talking about them in detail later in the presentation. The objectives of any mission can be measured by the effectiveness of its operation. Measurements of effectiveness quantify the capacity of the system to have the required performance and comply with the rules of the competition. In this competition, we will use a Briggs & Stratton 10 horsepower OHV Vanguard Model 19. It will be a 4-cycle motor and it cannot be modified. The powertrain must be capable of providing power to the 2 rear wheels. For the 2023 competition, it will be obligatory to have 4-wheel drive vehicle. Vehicle width should not exceed 64 inches. The length of the car and the weight are not restricted, but designers should consider that the race courses are made for cars 120 inches long. A minimum of 4 wheels is permitted for the car, and it should not be placed in a straight line. You can have more than 4 wheels if you want, but it should not be placed in a straight line. Chassis and suspension clearance from the floor to withstand hits of any terrain type. The design should perform safely while carrying a driver of 6 feet and 3 inches tall and with a weight of 250 pounds. The driver must be wearing the complete driving equipment under these conditions. Also, the vehicle must be capable of operating in rough terrains of any type of weather, including rain, snow, and ice, and also the terrain can have rocks, sand, mud, and shallow water. The measurements that will be used to measure performance and ensure safe operation will be digital engineering analysis. Among them are those used in the SolidWorks program. One of those is the von Mises analysis, the safety factor analysis, and displacement analysis. All of these 3 will be applied to the suspension and the design chassis. SolidWorks simulation and torque tests will also be used to ensure that the engine and powertrain are compatible and capable of moving the total weight of the vehicle. The target metal used for chassis design is chromoly 4130. The design will be made using different metals to try hardness and also analyze the impact of each metal cost on the final price of the vehicle. The design should keep a driver safe during a side, front, and rollover impact, which will be analyzed with the SolidWorks test. We will target a safety factor for our parts of over 1.5. Now I will leave you with my partner Heriberto Cotto, which will have the QFD and the problem planning.
My name is Heriberto Cotto. I will be talking about the quality function deployment, or QFDs. Since we have the MOPs and MOEs, we need a way to see the connection between customer requirements and technical requirements. For this reason, we use this diagram, which is called the quality functional deployment. On the left side of the diagram are placed the MOEs, or customer requirements, and their weight of importance. At the top of the diagram are placed the MOPs, or technical requirements, and symbols of arrows or circles. If these arrow symbols points upwards, it indicates that if the MOPs increases in value, it is of better benefit. If the arrow symbol points downwards, it indicates that if the MOP decreases value, it's of better benefit. And the circle indicates a specific value that is required. In the center part of the diagram, the numbers 1, 3, or 9 are placed to indicate how related the MOEs or MOPs are, with the lowest number meaning the least relationship and the highest number having the greatest relationship. Finally, the scores found at the right and bottom of the diagram establish where the MOEs were covered correctly or whether any technical requirement had to be included to meet the specific needs of the client. Now, we're, we're going to talk about the preliminary project planning. Since the start of this trimester, the second week of August, on the 9th, we informed the professor who would be the members of the group and the project to be carried out. The third and fourth week of August, we were working with the pre-phase A, and we presented to you today, September the 1st. Then, during the rest of the week of September, of this week of September, as a group, we will be working on the following topics: technology assessment at system level, trade studies, project mission architecture and interfaces, budget and budget analysis. Eventually, each member will work a subsystem as follows. Gadiel will be working the chassis, Anthony the powertrain, Jose the miscellaneous, and myself, Heriberto, will be working on the suspension. Finally, we are proposing the fourth week of the month on September 29 as the date for our Phase A presentation. These are the references, and this would be all for the group presentation of Pre-Phase 1. Thanks.